From spaceflight's earliest days, the need has arisen to rendezvous and dock several vehicles. Extremely delicate manoeuvres at walking pace whilst orbiting the planet at absolute speeds of close to 28,000 kilometers an hour. In the early 60s, Vostok and then Gemini spacecraft flew in tandem. The first ever docking occurred in 1966, a Gemini 8 capsule with an uncrewed Agena rocket stage. This paved the way for the Apollo program, 6 landers blasting off from the moon for crucial rendezvous with their mothership to return the astronauts to Earth. Soyuz craft allowed cosmonauts to permanently occupy the Salyut and the Mir space stations. In 1975, East and West made headlines when their Apollo and Soyuz craft docked with historic handshakes, a landmark in international space cooperation.
Booster ignition.
And from 1998, the International Space Station has required regular visits. To date, a total of 58 dockings of the shuttles, the Soyuz crew and the Progress supply ships. The ATV introduces a new generation of spacecraft capable of entirely automatic rendezvous and docking.
First of all, we have to do the technical aspects of actually doing this rendezvousing completely without man in touch. But one of the most critical areas of design is that we have to make it really safe. There is no way that we can hit the space station too fast or too hard or have any danger at all to the astronauts.
From its conception, the design of the ATV has relied on multiple systems and techniques to ensure a safe and successful mission. After raising its orbit to some 400 kilometers, the ATV will come in sight of the ISS, and from about 30 kilometers distance behind and 5 kilometers below, it will close in on its target.
We are using GPS navigation, we are using star tracker devices, we are also using for the rendezvous, and these are the 2 critical optical rendezvous sensors, telegonimeter and a videometer. They are 2 laser-based sensors. And this is quite an achievement. It was part of the most critical in terms of new developments.
Unmanned then, but man-rated, the ATV has unique capabilities.
It does an automatic rendezvous in a fully autonomous manner, as opposed to Progress or Soyuz, which are the only other space vehicles to do automatic rendezvous, but where the vehicle needs cooperation of the station. In the case of ATV, it recognizes by itself where to go.
Like all spacecraft, the Jules Verne has undergone exhaustive testing during each phase of development and final assembly. Its navigation systems have been qualified with countless software tests and fully representative simulations. The software is the most sophisticated ever developed in Europe. At a unique test center near Paris, a robotic arm equipped with the ATV sensors locked on to the retro-reflectors on a full-scale version of the aft docking port of the space station, carried on a mobile platform 300 meters away. Collecting real-time data, distances, angles, relative rotation and lateral motion, the tests replicated the magical moments of the final approach.
It's a bit like shaking a hand. We have these optical instruments which are going to be looking at the sensors. We will get a reflection from the space station. We will be able to know whether we're actually in the right corridor that we need to go at, if the satellite is at the right angle, and whether we're going right in close enough where we can eventually dock.
Any single fault then can happen, and this complex, fully redundant system will still work. Any two, and it will still be safe. But even so, in order to be super safe, there is a third monitoring and safety unit.
If we get into any sort of trouble and people feel it's dangerous, we can call on this independent system and we back away from the space station and are completely safe.
After several approach and retreat demonstrations, the Jules Verne will move in towards the Russian Zvezda module with its well-proven docking port.
Around what you have is called the docking ring. It includes built-in connectors for data, power, fuel, and also the mechanical hooks to make firm attachment. In the middle, you have the intelligent head that detects contact, capture, and when it is retracted, forces the airtight connection.
ATV ground, ATV fly.
After its release by Ariane, the ATV's progress will be supervised by the dedicated control center in Toulouse, in constant contact with those in Houston and Moscow, and with the ISS astronauts eager to welcome their supply ship, but on their guard with an abort command button.
They will have trained for a few days beforehand on an onboard simulator where there is a lot of malfunction. So when ATV approaches, their mindset is there may be this malfunction or this one, and they are spring-loaded to jump on any anomaly. They must ensure ATV either touches at the right place, at the right speed, or doesn't touch at all.
Europe's new generation space transport vehicle, with its unprecedented cargo and reboost capabilities, will service the space station for many years and could become a unique asset after the shuttle retirement in 2010. Its advanced technologies will no doubt have other uses, for robots to recover old satellites and space debris, to return planetary samples back to Earth, for the remote construction of large space structures, and notably for interplanetary journeys.
One of the strategic reasons why the European Space Agency was so keen to have our own automated transfer vehicle was this technology is exactly the one you need to go and rendezvous with other craft that are going to go, say, for Mars. We're going to have automatic rendezvous and docking near Mars. And ATV, we've shown that the technology works and we can do it in Europe.